Hey guys, welcome to GER Hub Mathematics and Statistics lessons. In today's video, I'm going to be talking about binary operation. Binary operation is a very important topic in mathematics that helps you understand the laws and the rules behind so many things we've been doing all along the way in our mathematics, and you need to watch this video. If you haven't subscribed to the channel, please subscribe now to the channel by clicking the subscribe button below, and make sure you smash a like on this video, and I'll see you. So guys, welcome to my class on binary operation. I'm going to start this video with telling you two things I'm going to be using in my definition of a binary operation. So I'm going to be defining binary operation and giving you examples, popular examples of binary operation. Before I do that, I'm going to tell you two notations we are going to be using in my definition. So let's start with the notations we are going to be using. Now, the first notation is what I'm going to be using to represent a binary operation. So I'm going to say here, let asterisk represent a binary operation. Okay? So let asterisk represent a binary operation. So this symbol is what I am calling asterisk. Okay? So this symbol is called asterisk. And wherever I use this in my definition, it shall be representing a binary operation. Okay? It shall be a general notation for a binary operation. Now the next symbol I'm going to be using, please come with me, is what I'm going to be using to represent a non-empty set. So let S be a general non-empty set. So wherever you find S in my definition and wherever you find asterisk, they shall respectively represent a general binary, a general non-empty set and a general binary operation. Now that being said, let's start with the definition, and I'm going to call this definition 1. And what will definition 1 do? It will answer the question, what is a binary operation? So a binary operation, I'm putting in bracket, denoted by asterisk, is any rule of combination. A binary operation denoted by asterisk is any rule of combination of any two elements, say A, B, that are members of S, in which case S represents a non-empty set. So a binary operation is any rule of combination of any two elements, say A and B, that are members of S, a non-empty set. Now I'm going to explain this definition in detail. You would come to realize eventually in my explanation that all along the line, or all along the way, we've been using binary operations unconsciously or consciously in our study of mathematics. Now, so come with me and let me explain that definition to you. So, from the definition, what you are going to realize are the following keywords. Now, what is a binary operation? A binary operation must be a rule. So, I'm going to underline the word rule. Binary operations are rules. Okay? Now, the next question you have to ask yourself, what kind of rule is a binary operation? A binary operation is not just a rule, but it is a rule of combination. Okay? So it is not enough to say a binary operation is a rule. It is not just any rule, but it is a rule of combination. It is a rule that combines. Okay? Now, what kind of combination does what we call a binary operation do? A binary operation, aside being a rule of combination, specifically combines elements. These elements could be numbers and they could be algebraic entities. Okay? So a binary operation combines elements which could be numbers or algebraic entities that are drawn from a non-empty set. And the word non-empty speaks for itself. The set must be a set that contains elements. Okay? Any set that contains elements is regarded as being non-empty. So binary operations are always defined on non-empty sets. Okay? So that being said, you would come to realize that a binary operation all along the way is what we have been using in our day-to-day activities, and I'm going to explain that. So let's look at common examples. Let's look at common examples of binary operations. So common examples of binary operations we've been using all along are: one, you would come to realize that one binary operation we've been using all along the way has been this one: addition. Addition is a binary operation. The second binary operation we've also been using all along the way is subtraction. So you won't be surprised that we've been using this as a binary operation, but we never knew it was actually a binary operation. I'm going to be explaining why each of them are binary operations, but let's mention them first of all. So the third one is multiplication. So multiplication is another binary operation we've been using all along. And the fourth one is division. So these are popular binary operations we've been using all along. Now, the question is, why are these that I have mentioned binary operation? Addition is a binary operation because it does what the definition says. A binary operation is a rule of combination of two elements, any two elements from a given non-empty set, X. Now in this case, let us examine addition. Now this video will focus on defining the binary operation and giving you examples of the binary operation. So I'm going to explain, to end this video, what makes addition, subtraction, multiplication, and division binary operation. Now, how are we going to do that? We are going to check each of these operations side by side the definition. If these operations do what the definition says, then they are clearly binary operations. So if addition is a binary operation, if subtraction is a binary operation, if multiplication is a binary operation, and if division is also a binary operation, it means that they must be able to combine two elements chosen at random from a non-empty set. Now, if I give a non-empty set as an example, so let's consider this. If I pick an example as a non-empty set that contains 1, 2, 3, 4, 5 as elements of that set, and define on this set. Remember, every binary operation must be defined on a non-empty set. Now if I pick this non-empty set, clearly it is non-empty because it contains elements, and in this particular case it contains 1, 2, 3, 4, and 5. So if I pick this set, you will notice that I can define on this set the binary operations addition, subtraction, multiplication, and division. Meaning that from this non-empty set, I can pick any two elements at random and add them. Okay? So a binary operation is a rule of combining two elements chosen at random from a non-empty set. So you will notice over time we have been doing things like this. We've been performing operations like 2 plus 3 giving us 5. We have been performing operations like 2 times 3 giving us 6. We have been performing operations like 4 divided by 2 giving us 2. And we've been performing operations like 4 minus 2 giving us 2. Now, what have I done in the first example? I have chosen two elements, 2 and 3, from this non-empty set, and I have used addition to combine them. What does addition, or what did addition do in this case? Addition helped me combine 2 and 3 by bringing them together, fusing them together to give a total result of 5. What did multiplication do in this case? Multiplication helped me combine 2 in 3 places to give 6 as a final result. What did division do in this case? Division partitioned 4 into 2 places to give me 2 as a final result. And 4, from 4 I subtracted 2 to give 2. Now, addition, multiplication, division, and subtraction, all of them did one thing in this case. They obeyed the definition of a binary operation. And what was that? It was the very fact that each of them used here was used on any two elements chosen at random from a non-empty set for combination, whether the combination was by means of multiplication, the combination was by means of division, the combination was by means of addition, or the combination was by means of subtraction. All of them were combining two elements chosen at random from a non-empty set. I hope with this short video you were able to understand what the definition of a binary operation is and typical examples we've been using over time of a binary operation. Please go over this video, smash a like on the video, and do well to subscribe to the channel if you haven't subscribed to the channel, and I'll be seeing you in my next class on binary operation. Thank you very much.